past. Some of you guys will wonder, who are these guys? What do they do? So I'm going to spend 3 minutes to just quickly give you an overview regarding who we are. And we are basically, I myself was in Google. I was engineering director. I happened to attach with Project Fi as well. Hired a lot of people in Google and found it was incredibly hard to find a job or hiring people. So that's why we said we want to build a platform to make the whole job search a lot easier. And we want to find a user easy and intelligent way to help people to land their dream job. And you don't need to go to search for millions of job descriptions to find out 2 or 3 or 20 or 30 or 100 for you to apply, then waiting for most of them don't get a response to you. What we want to do, we want to deeply understand what you're looking for. Understand your preference, your value, your experience, your strength is, and then use machine learning to do intelligent matching. Only present those ones we think are great fit for you. And then we not only tell you the companies that we think are great fit for you, we also tell you the reason. So if we match you with, let's say, DD, then we'll tell you the reason, 1, 2, 3, why that is a great company for you. And probably sometimes for those companies, you may not know. But then with this reason, hopefully, you're able to discover some opportunities. Otherwise, you would not know. And so that intelligent matching itself is just a first step. After that, the key thing is that you need to have the employer to respond to you. So basically, we signed up with a partnership with a lot of companies. They promise for people with experience, with 2-year or more experience, when you apply, the guaranteed response. And in some cases, a guaranteed interview as well. So that's, and currently we partner with a lot of what we call the faster growing companies. So that means the company growing very, very fast. Each year, their headcount probably either double or more than 50%. Most of those companies are unicorn companies. We partner with about 20 unicorns. The Uber, Dropbox, House, Ant Financial, and a bunch of those ones, really big. And then we also have a bunch of Series B or Series C companies. Here on the screen, you have some logos, but we have even more partners. So that's just a quick overview regarding the primary thing that we do is really if folks are looking for new opportunities. We try, especially you're very busy, you work in large companies, you're very, very busy, but you're just not very super pleased with where you are. You want to spend a few minutes, set up an account, then we'll do the rest for you, make it super easy for you. And in addition, we have a bunch of additional content like events. We also write blogs. We also have Leap moments, which we invite the leaders in the industry to share moments that have very meaningful impact to their career. And we found the Leap moments are very well liked by our users. Generally, for the email, we send this notification about those moments to our users. Usually, you say email open rate is probably 3 to 4%. Our email rate is 35%. So that's how much people like the content. So that's a very quick plug regarding where we are. Next, I'm going to turn over to Prithvi Subburaj to give the talk about Project Fi. So before I turn over to him, I want to do a very quick intro. I had the opportunity to work with Prithvi for 5.5 years in Google. So we work super closely with multiple projects, from Google Offers, Google Shopping, Wallet, and then Project Fi. Prithvi is one of the most talented engineers that I have seen in Google, not only from technical perspective, but also serve as a fantastic leader. And folks, engineers really love him as a manager, and also has a very, very sharp business view. So Project Fi serves as a very perfect showcase for what he can do. And very hard technical challenges, plus a very challenging business challenges. How do we move the ecosystem forward? So tons of hard work has been done, tons of exciting technical challenges the team has been tackling through. So with that, it's my honor to introduce Prithvi Subburaj.
Thank you, Richard. Thanks for the kind words. So I have known Richard for 5 years. It seems like forever now. So the part that he didn't mention is that he led Project 5. He was my manager at Google, and I took over the job when he went to start his own company.
We need a stronger leader.
Definitely. So the one piece of career advice I can give for folks is, if you ever want your boss's job, convince them that he's too good to start a company, and then you take his position over. Worked out for me. So jokes apart, I know that Leap is doing a really awesome job. I have my own friends have used Leap several times, and they have nothing but good things to share. So congrats on the great work. I hope you continue to do the awesome work that you started. So I joined Google as an ads engineer, typical of a lot of people at Google. So I mostly the thing that I did was display ads. So all the great ads that you love in between YouTube are the ones that I started doing. At some point of time, I got really obsessed with those things that I wouldn't skip an ad in between YouTube. So that's when I thought, okay, I should do something else. Since then, I've shared a long journey with it. So here, like with every talk, we'll do a brief spiel on how Project 5 came to be, why, what, and why we're doing what we're doing. So, how many of you have ever used a car phone? Thanks. We have a couple. So this is an amazingly young audience, or people are not willing to admit their age here, one of the two. So car phones were pretty prevalent in the 70s. So I kind of think of this as the beginning of the cellular networks, right? So you can, the car was attached to your phone. You can reach anybody at any time that you wanted. And this was like a great breakthrough in the 1970s. Right now, we are talking about connected cars. Cars can talk to each other, right? But this is something of the 70s. And towards the end of 70s, the first mobile phone came to be. Doesn't look that mobile. You have to carry that huge piece of equipment around. But for just $1,200, you could get hold of the best piece of technology at that time. Looks like you pay somewhere similar to the same amount today for certain brand of phones a year. Anyway, so this was the birth of what we call cellular networks. So the name cellular networks itself is a misnomer, right? I mean, cellular has nothing to do with electronic devices. In 1970s, if I had gone and asked somebody, or I said something like, I have a cellular problem, people would have been like, oh, you go to a doctor. Right? I tried the same thing with my wife today morning. I said, I have a cellular problem. And she was like, it's your network, go fix it. Right? So we are in a different world where cellular networks have gotten in deep to every part of our life. The word cell came to be from a geographical area wherein a baseband was constructed to serve a cell of a certain geographical size. A bunch of cells came together to provide a network, and that's what we call the cellular network. All right. So then we moved into the age of internet, right? 90s, when I got hold of the first dial-up connection in India, it changed my life. I was always online. It changed my life and that of my parents as well. The phone bill increased drastically in that month or so. But we entered into a world of Uber connectivity. Then this was in the 99s. So I moved to US, and my first phone was the Moto Razr phone. It was an amazing piece of technology. I felt so cool flipping on and off the phone. I still have one of these at home, though it doesn't work. Those are the times of unlimited talk and text after 9 p.m. So you had to wait till the clock takes 9, and you take the phone and you talk to your loved ones. It was done as a means to control congestion. Essentially, what they found was it increased congestion at that period of time. Everybody was waiting till 9. Didn't really quite work. Then came the world of unlimited text and data access with the Blackberries. Blackberry was my first device when I took up my first job. It felt so cool to go through emails. It felt really businessy-like. Then we ended the generation rather amazingly well with the advent of iPhone and Android devices. It just changed everything. So when Sundar took the stage 2 years ago and Google I/O, he set the stage for the AI first world, wherein everything is moving towards an approach to machine learning. Richard's trying to use machine learning to beef up the recruiting industry, and we have seen a lot of these things already play in several areas. In hardware, we are talking about TensorFlow units right now. In software layers with Google and Google Assistant, we're trying to reach more and more surfaces, and AI is becoming more and more prevalent than ever before. As we get into this world, one of the things that we need to ask is, can networks be smart? Are there applications of artificial intelligence and machine learning that can be applied to networks themselves? So we'll go through some of these things and some of these use cases with Project Fi, and how we are barely scratching the surface of what is possible here. Now, there are several ways to draw a map. So coming from Google, the one way to draw a map is to draw a map based on YouTube watch time across the world, right? So what you're seeing here is, if you're seeing a green, then it is people have reasonably good connectivity. So you can watch standard definition streaming most of the time. Yellow, not so much, and red is pretty bad. And empty spaces, maybe we don't have data for the most part, is what you should get from this. So one of the cool things you'll notice in this map is you see how humans have settled in a way, right? So again, you can easily spot the river of Nile here in the map. A lot of YouTube being watched there. You can see probably the road leading from Anchorage to Fairbanks in Alaska. So good YouTube, good amount of YouTube watch there. So settlements around Australia. That's South Korea. That's North Korea. No data in North Korea because people mostly are on Twitter, I hear, these days. Thank God, I hope not. So anyway, so technology has reached to every nook and corner of the world, and by certain counts in the 2020s, we are expected to see as many as 25 billion connected devices, right? So if you look at human population, 7.8 billion, more than that. That's why these days we are talking about IP exhaustion. We need to beef up our networks to scale up to this massive amount of data that's going to go through the networks. So the question is, are we really prepared to handle this amount of data? Should our networks become smart? All right. So when we started looking at this problem 3 years ago, right around the time we were conceptualizing Project Fi, a little before that, we realized the need to understand the entire spectrum. So there are different elements that play in the user experience. You have the device context, you have the network context, and you have the user context. We fundamentally believe that unless you understand both the depth and the breadth of this problem, it is not possible to provide a very, it's not possible to solve the problem. It's not possible to give a great user experience. So on the device context, we needed to understand how the device behaves under certain network conditions. Just because a device works great in a certain network doesn't mean that when you port a device to another network, it would work. There are different bands that device comes with, different antennas, different processors. So a lot of things change with devices. Network itself needs to scale with rapid growth. As if there are congestions, you need to find a way to automatically adapt your network too. And networks themselves are very ephemeral, so you need to make sure that you can react in real time for any changes. And finally, users. Users are the most tricky part of this equation. So you need to kind of guess what they really want and adapt to the particular circumstances. Some users might favor higher throughput, while others might favor better voice quality. It's pertinent to understand what really the user needs and change things accordingly. So we realized that we needed to do this, but how do we do that, right? And that's kind of the birth of that's where the birth of Project Fi. So Project Fi is Google's wireless carrier network that aims to explore opportunities in the wireless space by innovating across the stack. So we wanted to look at this whole problem in the entirety and say where are all the places that we can improve, make it better, and provide a great user experience. And one of our goals is to drive innovation in this industry So to that extent, we always try to develop features and do things that benefits the broader Android ecosystem, the broader telecom ecosystem, so on and so forth. Being a carrier ourselves, we feel like now we are part of the larger carrier community. Now we understand the problem. To begin with, we speak the same language. And now with our stronger ties both in with the Android ecosystem, with our OEM players, and with the carrier partners, we believe we can truly change this. Right. So what is Project Fi? I know there are some Project Fi users here for others. So Project Fi is this wireless network that is built on top of multiple networks. So unlike typical wireless MVNOs, we have multiple carrier partners. Project Fi SIM card in the US hosts 3 carrier networks, T-Mobile, Sprint, and US Cellular, and we automatically switch between these different networks to provide you the best connectivity at that particular point in time. We also provide roaming access in 135 countries. The plan is extremely simple. It's a simple pay-as-you-go plan. It's $20 per talk and text, $10 for every gig of data. You pay the same $10 no matter where you travel to. I go to India, I still pay the same $10. When I go to when I visit any other place, I still pay the same $10. And we refund any unused charge back to the users. So one of our fundamental principles was to keep this entire pricing fair and think about act in the user's point of view. So you'll see a lot of this philosophy throughout Project Fi as it presents other things. At this point, we are available only on Google devices, so the Pixel and Nexus line of devices. The recent change, we announced our first Android One device in the US in terms of Moto X4. Project Fi supports Moto X4 as well. I already talked about smart switching. When it comes to network, we don't limit ourselves to cellular networks. Wi-Fi, I believe, is a core piece of this puzzle. And we'll talk a lot about how Wi-Fi is broken, and that's something that we are very passionate about fixing. With Project Fi, we'll auto-connect you to a bunch of hotspots across the US. And we have a bunch of extras. We support Wi-Fi calling. There is free data-only SIMs, and we run. So far, the way we have grown is through word of mouth. So through we have a bunch of passionate users. They refer other people, and that's we have seen a strong growth in terms of word. So that's what Project Fi is about. I'll jump into some of the technology challenges and area of opportunities that we see. So let me talk about network selection and why it's a difficult problem. So when we talk about cellular networks, we are talking about kind of fixed frequency bands, right? I mean, it's why is it fixed? So you can go to a low frequency band. It's very good for penetration into buildings and other places. But the problem with low frequency bands is you need really big antennas, and we are in this world of mobile devices. So you have to really be careful about how much space that you use on these devices. Then you can go to the other spectrum. You can go to higher frequencies. Higher frequencies don't have the great penetration capabilities. They can't go really high because there are some health-related issues that would come. So you have this segment within which you can operate. The best analogy you can think of it is, you're on the road. There are 4 lanes. How do you increase capacity and thereby boost data speeds, reduce congestion for the users? It turns out there are only 2 ways, right? You can build an extra lane in one-on-one that takes forever. By the time they finish, it's already more congested. And the other way to do that is you change traffic patterns. In what we see up there is you can have carpool lanes, which I don't think is a great idea, but you can change traffic patterns to ensure that people can move around, change lanes. But at least out there in the road, things are a little easier because when a particular lane is blocked, you can switch to the nearby lane and move on. Not the same. That's how the analogy breaks in the telecom industry. Every telecom operator has their own spectrum. It's licensed. You pay for it. Even when one particular spectrum is massively utilized, there's congestions. There's no real way to switch to the other lane without changing your data plan from one network to another. So, so this is where I think, with network selection, we truly believe we can achieve global and local maxima and drive the right user experience. So, but it turns out it's not an easy problem, right? So what do you optimize for? I mean, this is a classic, learning problem, right? Do you optimize for better coverage? That seems right. Or is it better voice quality? Do you optimize for faster throughput? Whenever you switch between networks, it draws in a kind of pattern. So do you optimize for battery? Do you optimize for low latency? Do you protect against outages? So there are these different parameters for which you can tune for, and there's no right or wrong answer. Right? It really depends on the individual who's using it. So switching is non-trivial. The reason it's non-trivial is a device has one radio, right? It is not a dual radio wherein you can look at both the networks at a given point of time and decide which is the best network and switch almost immediately. You have to predict. Right? You need to almost predict saying that, oh, the user is better off on this particular network in this cell as opposed to the other. And we need to optimize for a ton of dimensions. We saw a bunch of these dimensions in the previous slide. It could be data time, it could be throughput, it could be voice, it could be a number of things. The other thing that we need to do is we have to get extremely predictive. We need to minimize the number of switches. You can't keep people switching back and forth. Switching networks takes time. As in general, you can see what is happening behind the scenes is you need to scan the entire band spectrum. You need to figure out what spectrums kind of right now available, whether I can latch onto the spectrum and then get onto it. This takes time. Right? And the more you do it, it hampers user experience, and you want to control how many switches there are. And prediction is super hard. Right? You can use history as a judge to say that in this particular cell, network A is better than B. But networks are ephemeral. Network conditions keep changing. So you need to almost figure out what is the best way to use history, but also local data to correct yourself. And users value different attributes. So users are the kind of the most crazy piece of the puzzle here, right? I mean, sometimes when users say that they want X, I mean, they really don't want X, they want Y. And sometimes so it is very hard to figure out what they really value and adjust a network to that. If you look at our phones, we have a cellular network stack and you have a Wi-Fi network stack. It is like it's like two brains which doesn't really work with one another. There must have been so many times that people have to literally kill their Wi-Fi network to go to cellular and turn off your data so that you don't use a data network to just use Wi-Fi for calls. Users constantly have to make this choice because they need to think about things which should just work rather automatically. So these are all the things that make switching non-trivial, and it's a hard problem. We have done certain things to mitigate these, but I would say that we are at a very, very early stage on even getting switching right on 5. But the access to multiple spectrums, the one thing I can say is what we have seen has definitely improves reliability. So network switching, by far you can think about it as it protects you against outages. During the recent unfortunate events of hurricanes in both Texas and Florida, we saw this happen throughout our network as cellular towers are going down. Folks were switching rapidly from one network to another. You could see this data in real time and how hard weather conditions brought down some towers and users had to switch on to other networks. So generally, we feel that switching has improved the overall reliability for users. Many times, users there are local outages that not on the scale of hurricanes that we see that results in bad user experience. So having access to multiple networks definitely helps boost reliability. Coverage. So this goes back to my analogy of roads. Having access to multiple lanes, and in this case, multiple frequency bands, we are able to determine which is the best network to keep the user on. If you believe that there's one band that will be faster for you, and we can switch you over to that band and keep you on that band to get the best user experience for you. So it improves coverage. Cost. And So this is where Wi-Fi plays a good role. So the more Wi-Fi networks that we can get you access onto in a secure fashion, that lowers your cost on data. So you don't end up paying so much on data. You offload it to Wi-Fi, and overall the user saves some cost as well. There are probably a bunch of other benefits, but these are the few benefits that we have come to realize. So the other thing I'll talk about is network access. So one of the biggest friction points in networking is, how do I get access to a network? Right? I mean, if you need to go through a captive portal to get access to Wi-Fi, then a bunch of users don't get access to Wi-Fi. If you need to actively decide to turn off Wi-Fi and get on cellular, you should expect users not to do the right thing, or because they have to actively make a choice every single point. So Wi-Fi is, as I said, is an extremely important piece of puzzle, but it has a ton of issues. So in a survey that we ran, we found that 33% of users get stuck on bad Wi-Fi at least once a month. So this is nothing to do with Project 5, so it's a general broad-based survey that we ran, and we saw that this was a big problem. 70% of the users believe that public Wi-Fi can lead to identity theft. So in general, there's a perception problem with Wi-Fi. It is true that you have to be careful when you connect to a Wi-Fi network that's unsecured, but it is more likely that the data gets stolen. But there's a big perception problem. The users are really scared on getting access to public Wi-Fi. User experience is one of the things that is really broken here. We call this the famous parking lot problem. Right? You're connected to Wi-Fi, you're walking away, you're going to the car, you're still connected to the Wi-Fi, you're streaming music and it breaks. And the only way to get everything back on is kill Wi-Fi, get on LTE, and streaming starts again. It's pretty painful. You think that us and technology should have solved it so far, it's a hard problem. It's not being solved. But these are the kind of things that we should be looking at solving for users. Accessibility. So this goes to my previous example on users, people requiring manual intervention to manually decide which network they have to be on every single point of time to get to a better user experience. Finally, you can't just assume that all your communication services will work on Wi-Fi. You can't assume that you'll receive an SMS or be able to send an SMS when you're on Wi-Fi. So unless your network provider has enabled you or provides you the service to get these SMSs over Wi-Fi, things won't work. So we are passionate about solving some of these problems, and there are some early things that we have done here. Wi-Fi Assistant is one such feature that we launched with Pi and is now available on all Pixel devices. So Wi-Fi Assistant, what it allows you to do is it automatically connects you to any open Wi-Fi access point that we think is high quality. So we use history that's collected in the past from other users who are connected to Wi-Fi. We determine that this Wi-Fi is a good network and we can get you on Wi-Fi. But still there's a problem, right? I'm connecting users to an automatic Wi-Fi network, and there is a problem of security. So to deal with that, what we do is we automatically open a VPN so that all your data that is going through this network is secure. But at the same time, you're connected to Wi-Fi, so you offload a bunch of data and save, and there are good savings there as well. In our philosophy to enable not just Pi, but a broader range of devices in the Android ecosystem, we have seen this technology make it based to all the two generations of Pixel devices and previous Nexus 9. The other famous problem. So how many of you have turned off Wi-Fi and forgot to turn it on back again? It's a good number, right? So we found out that 60% of folks who turn off Wi-Fi forget to turn it on back again. Right? You are connected to a really bad Wi-Fi network. The only way to get access is by turning off Wi-Fi. You turn it off, all's good, everything works. You come back home, you're still on LTE, and all your Google Photos get uploaded over data. Not a good problem to have. So we saw that many users suffer from this issue, and this is something that we thought that we could get in and fix with some code technology and algorithms. So we launched Auto Wi-Fi with the latest Android release. So if you have Android O, now Auto Wi-Fi enables you to, even if you turn Wi-Fi off, and we know that this is a network that you have previously connected to, you'll automatically turn Wi-Fi back on so that we help users save on data, among other things. Again, this is a tricky problem, right? I mean, if you just turn Wi-Fi off, I turn it back on again, it's like, oh, what is Google trying to do behind the scenes, right? So, so we had to get it right, and there are a lot of algorithms and experiments still being run to make sure that they're doing the right thing for the user. So all these set of things fall under the category of friction, right? Users are trying to actively make a choice when they shouldn't be thinking about it. Networking it's kind of like utility, right? I mean, it's like water. It should be completely invisible to the user. The only thing that should matter for him or her is whether they are able to do what they really want to do. Another place where we saw friction is with your device activation experience. So you get a phone. The first thing you have to do is get a SIM card. There's a really painful process that you need to figure out how to get the SIM card out and put it back in. We ran a bunch of user studies, and a couple of users literally broke their phone trying to get their SIM card out. So it is a pretty painful. We thought it was a pretty painful user journey to do something to even get access to the network in the first place. So with that, we introduced the first smartphone in the US, which carries an inbuilt eSIM with it, which will be the Pixel 2 line of devices. So today we get a Pixel 2 phone on 5. You wouldn't need a SIM card. You will log on to your, if you're previously signed up on 5, you log on to a Google account. We automatically download profiles to the SIM card, and voila, you get access to the cellular network. So again, another point of friction that prevented users from getting access to network broken. You don't need a SIM card shipped to you to get access. So so we were pretty nervous before we launched eSIM because it's completely new, and we were worried that users would find it very, very hard to understand the concept of eSIM. So, but when we ran our user study, there was a lot of data that gave us confidence. Indeed, only 69% could actually put their physical SIM card correctly into their devices. They had to figure out which way to put the SIM card. They had to figure out how to get the SIM tray out. It is a very, very stressful. We saw it as a very stressful experience for users. But on contrary, when they went through the eSIM flow, it was like one step after another, and we almost 100% success. Right now, this experience is in the wild with the Pixel 2 lineup of devices. We'll see how the real experience in the real world also is. So what I've shown so far is kind of a flavor of things that Pi is doing. Right? Just by being Google being a carrier itself, they're able to try these rather new and innovative things. And with projects like eSIM and Wi-Fi Assistant and Auto Wi-Fi, the thing that we are trying to do is find a way to experiment and then give the great technologies and innovations that we come up with to a broader ecosystem and try to push the industry forward, saying that we have done it, we have tried it, we see it works. In case of eSIM, we know it works. Now it's probably trying to find the right partners and to push it further. So being a carrier, so being an insider, like being an insider in Washington can do a lot of things. Being an insider here lets us do a ton of great innovations. So service. So it turns out that Southwest loses just as many luggages as United or any other carrier out there, but fewer people call Southwest customer support. It's because they have built a great brand. Users trust Southwest more than, say for example, United. So building a brand that users trust and thinking from the user's perspective is truly, truly important. So one of our core pillars to try and build the best service possible, and always think from the user's point of view. And being a small carrier, we have to really do things differently out there. So the first thing where we talk about simplicity is in our plan itself. We spend an awful lot of time trying to get our billing right. One of the problems that we found in general with network providers or internet providers, bills can get really confusing. So it's very hard to design for the bill. So we spent a lot of time honing our billing. We wanted to make it super simple, and that's where the simple plan was born, and it's very easy to understand the fiber. The second thing is transparency. We are extremely transparent, or we try to be very transparent on what we can do and what we cannot do. So if we think that we can't provide you the best coverage, the best thing would be is to direct you to the network provider who can provide you the best coverage. So that's something that we do very actively. So we believe that our network won't work out great for you. We try to discourage signing a profile at the very onset. And similarly, we work a lot on the user experience to make sure that you're not, when you're overpaying, when you're getting over, and you know exactly when to turn off and turn it on. Today, it is extremely easy to sign up and leave project. It's a click of a button. So you don't need to call customer service or just pause this and then so these are kind of the things that we try and ensure so that you can build a bit of transparency and think from the users. The other thing we try to do is we try to delight users in rather different ways. So what you're seeing on your right is a Lego set that we sent as a first holiday gift to all our users. We build a charging dock station with that. We try to be geeky and quirky. Sometimes it works. And we experimented with a bunch of kiosks in airports. You might have seen this kiosk in San Jose terminal and a few other terminals. So 5 users can walk up to the kiosk and get some funky gifts out there. Then we try to celebrate some magical moments. So as I said, we are supported in 135 countries. We provide unthrottled data access in all these countries. So previously, when I used to visit India, the first thing I did was go out, get a SIM card, and get access to the network. These days, I'm invited to this friendly plan around welcome to India, in this case, Iceland, and that you have coverage, you don't need to do anything, just go on with your life as is. So we celebrate these different moments. Okay, so where do we think AI and machine learning can really help, and what are our areas of focus in general? Right? So network selection, it's a core differentiator. We are trying to see how well we can adapt to users' needs by understanding the user better and optimizing for the right verticals. As I said, this is a very complicated problem. We need to be extremely careful and kind of algorithms we choose and the parameters that we give here. The other area where we think that machine learning can really help is fraud detection. One of our sister teams recently delivered the ability to detect spam calls on our dialer that is shipped in a bunch of shipped in all Pixel devices, Nexus devices, and now in other OEMs as well. The ability to use user data to detect that the call was spam and thereby tag things as spam and address this problem of spam calls has been like very rewarding. So this is one area where you can source in a lot of crowdsourced data and what is a spam call and not, and use that to do better things for the world. On the service side, you can be so this is like the future of customer support, right? I know this particular user has really bad service. I've seen them have drop calls or has been on 2G so on for a long period of time. Instead of them calling customer support, it will be great if we can identify those users. These are users are most likely to churn. They are having a pretty bad experience. What can we do about it? Right? So, kind of trying to predict the user journey even ahead and trying to reach out to them even before they reach out to us is kind of the future of this. Direct and react to social sentiment. So whenever we launch a new product, we try to understand whether we're doing well or not. You can kind of see these social sentiment trending up and down. What is the reception of, for example, a Pixel 2 or a new 5 features? So we try to analyze these things in different verticals. You can use the data to tune underperforming network entities. So we expect to see a certain throughput in a particular cell, and a bunch of devices are seeing it, while other devices aren't seeing it. If we find such data, you can also share it with our career partners and trying to retune these network entities to provide different experience to users. And we can use this data in a way to also, go to the extent of tuning device parameters to provide better network quality, voice quality. Indeed, what you have is you have the user context in terms of user level data. You're watching YouTube or whatever, and then you have all the stuff that is happening under the device. You see packet loss, so on and so forth. Then you understand the network conditions. So you put all these things together, and you apply deep learning algorithms on top of it. You can truly build a great network for users. And we are super excited about where we are. And we believe that we can make more and more improvements to this. So what's next? I said this earlier, connectivity has become like water. It's become essential to everything that we do. When we take our phone out, we just want it to work. We want everything to just work. Having friction or having accessibility issues or having to think about cost is a pretty painful problem for the user. So we believe in our goal to make connectivity completely invisible, and users should treat it just as utility. And we are barely scratching the surface on what is possible here. In Project 5, we have started this journey a little over 2 years ago. We are a fairly young network, but we have some passionate users. Some of them are here. So thank you for supporting us through this wonderful journey. And we continue to be testing, experimenting, and pushing the boundaries of the networking ecosystem and trying to push the boundaries of what is possible in the industry as well. For that, thank you. Thank you for having me here.